I'm going to go through this study guide, so if you have specific questions to a specific problem, just make sure you fast forward so you don't have to sit through this entire video, unless obviously you would like to. So the first part of this unit was direct, inverse, and joint variation. So if I look at number 1, it says state whether the following relations represents direct, inverse, or joint variation, or neither. So if I look at the first one, number 1A, it says A equals 2B plus 3. Well, that's nothing because direct variation doesn't have a y-intercept. Inverse variation is a rational function. And joint variation has more than 2 variables. So this is neither. If I look at part B says y equals x over 3. So that's a linear function where my b is 0, so this is a direct variation. C, if I were to solve this for y, I would divide by x on both sides. So I'd have y equals 3 over x. So since x is in the denominator, it's an inverse variation. If I look at the next one, if I again just come up here and solve for y, I'd have xy equals 4. So again, if I solve for y, I'd have y equals 4 over x. Since x is in the denominator, it's an inverse function. And if I look at the last one, it says y equals 4az. 4az, that's multiple, more than 2 variables, so this is a joint variation. Let's go ahead and look at number 2. It says write the equation for a relationship y varies inversely with the square of x and jointly with the sum of g and h. So I see y varies inversely with the square of x. So y varies inversely, so I know it's k over the square of x. So the square of x. And jointly with the sum of g and h. So jointly is just multiplied the sum of g and h. So g plus h, and put it in parentheses, so I know it's both. If we look at number 3, it says write the equation for a relationship A varies directly with 5 times B and inversely with the square root of C. So A varies directly, so K 5 times B, and inversely with the square root of C. So you could rewrite that to put your coefficient in front, or you could just leave it as is. Alright, let's keep going. It says the force of a wind blowing on a vertical surface varies jointly with the area of the surface and the square of the velocity. So when I go ahead and write this, it's going to say the force, so F, of the wind varies jointly, so that's K, with the area, so A, and the square of the velocity, so velocity squared. So it says if a wind is blowing 50 miles an hour and exerts a force of 75 pounds on a surface of 500 feet squared, okay, so I got to plug all that in. So I got to know where to plug in for F, what to plug in, and what to plug in for A, and what to plug in for V. So I know area is units squared, so I know area is 500. Here's K. And then it says a force of 75 pounds, so that's F. So miles per hour must be velocity, which that's how velocity is measured, squared. So I would type in 500 times 50 squared, and then I would divide that to 75 to get K, and I get 0.00006 for K. Yes, you can turn it into a fraction if you want to, it doesn't matter. So now I have F equals 0.00006 K, no, not K, A V squared. So now notice the last part of this problem. It says how much force will a wind of 75 miles per hour place on a surface that's 10 feet squared. So force is what I'm looking for. So my area is 10, and my velocity is 75. So I type all that into my calculator. So the force that I get is 3.375 pounds. If I look at the next one, it says the time required to process a shipment of goods at Walmart varies directly with the number of items in the shipment and inversely with the number of workers. So the time required varies directly with the number of items and inversely with the number of workers. It says 15,000 items were sold, and they were processed by 8 workers in 10 hours. So I gotta first find K. So I'd multiply 8 on both sides. I would get 80. And then I would divide by 15,000. So I get K equals 0.0053. So now I have T equals 0.0053 I over W. So now it says, how long would it take for 12 workers to process 20,000 items? So I would do T equals 0.0053 times 20,000 all over 12 workers. Type that in. T equals 8.9 hours. Let's look at number 6. It says, assume y varies directly with x, so y equals kx. If x is 4 and y is 30, find the constant of variation. That's k. I get 15 over 2. So now my equation is y equals 15 over 2x. Find y when x is 7. So I'd plug in 7, and I get 52.5. If I look at the next one, it says assume y varies inversely with x. So y equals k over x. If x is 2 and y is -3, find the constant of variation. So k equals -6. So I have y equals -6 over, x. So now it says then find y when x is -4. So now I have y equals -6 over -4. So y equals 3/2 or 1.5. All right, let's go ahead to the next problem. All right, so on these ones, I'm going to perform the indicated operation, simplify, and then state any restrictions on the variables. So I'm multiplying between, so I'm going to first factor the numerators and the denominators. So on 8, I can take out a 5x on top, and I'm left with x minus 2. And on the bottom, I can factor x minus 3, x minus 2. Nope, that doesn't work. Let's do, how about x minus 6 and x plus 1? And on the right, I can't factor the numerator, but I can factor the denominator. I first have to take out a 10, so I'm left with x squared minus 3x plus 2. So I'm now just going to go ahead and factor underneath so I don't have to write more work. So now I have x minus 2 and x minus 1. So now I can start crossing stuff out. So I can cross out x minus 2 with x minus 2 and x plus 1 with x plus 1. And I can cross out 5 and 10 to reduce to 2. And that looks like it. So I'm left with x on the numerator and x minus 6 and x minus 1 as factors on the denominator. Oops, and can't forget the 2 on the outside. So now if I state restrictions, x cannot equal, so in my answer, x can't equal 6 and x can't equal 1. So x can equal 6 and 1. So now if I come up a step to look at what I crossed out, here I'd crossed out negative x minus 2, so x can equal 2. And if I look over here what I crossed out, x can equal negative 1. So I'm going to do plus or minus 1, and then I got to include 2 as well. So let's go ahead and look at number 9. So number 9 is multiplication. I'm going to do the exact same thing. I'm going to factor the top. Factors of 20 that make negative 9 are negative 5 and negative 4. Factors of 14 that make 9 are 7 and 2. And then factors of 8 that make 6 are 4 and 2. And factors of negative 20 that make negative 1 are negative 5 and 4. So now I can start crossing stuff out. So I'm left with x minus 4 in the numerator and x plus 7 in the denominator. So now if I state my restrictions, x cannot equal. So if I look at this, my denominator can't be negative 7, so that's 1. If I go up to look at what I crossed out, x can equal 5 and x can equal negative 4. And over here, x can equal negative 2. So I said it can't be 5, it can't be negative 4, and it can't be negative 2. Let's go ahead and let's look at number 10. Number 10, so I'm going to put this over 1. So now I'm going to factor x plus 6 and x plus 3 all over 1 divided by x minus 6 and x plus 3 to get negative 3 and negative 18. And then I have x minus 6 and x minus 3. For the denominator, because I just factored, so now I'm going to keep change flip because it's divide. X plus 6, x minus 3 over 1 stays the same. Change to multiplication, flip the second fraction. So x minus 6 and x minus 3 goes on top, and x minus 6 and x plus 3 goes on the bottom. Now I can go ahead and start crossing stuff out. That's a plus 3. Sorry, I can't read my own handwriting. So x plus 3 crosses out with x plus 3, x minus 6 and x minus 6. So I'm left with x plus 6, x minus 3. So if I look at my answer, x doesn't have any restrictions, but if I go up one step here, x can't be 6 or negative 3. And if I go up one more time, x can't be 6 or positive 3. So I said 6 and then positive or negative 3. So those are my restrictions. So now we'll go ahead and do the exact same thing for number 11. I'm going to factor 3x squared plus 4x plus 1. So 1 and 1 and everybody's positive. X squared minus 4 is x minus 2 and x plus 2. Divide x plus 4 and x plus 2. Nope, that's not right. Let's do x plus 6 and x plus 2. All over x plus 1. So now cross out my factors that match. So I'm left with 3x plus 1 and x plus 6 all over x minus 2. So x cannot equal 2, negative 1, and negative 2. So if I go ahead and keep going, if I look at number 12, I'm going to have to subtract these. So the first thing I'm going to do is I'm going to factor the denominators. So if I factor this, this is x plus 2 and this is x plus 3. So my least common denominator is x plus 2 and x plus 3. So if I look at my first term is missing the x plus 2. So I'm going to multiply by x plus 2 on the first one, top and bottom. So if I multiply x plus 2 and x plus 2 on the top one, I have x, parenthesis, x plus 2 minus, now if I look at this term, I'm missing x plus 3, so I'm going to multiply x plus 3 on the top. And the last term, I'm missing nothing, so it'll just be minus 1. So then this is all over x plus 2 and x plus 3. So if I clean up the numerator, it's going to be x squared plus 2x minus 3x minus 9 minus 1 all over x plus 2 and x plus 3. So now I'm left with x squared plus x, nope, minus x minus 10 all over x plus 2, x plus 3. So before I get to circle this as my answer, I have to make sure the numerator can't be factored. So if I think about factors of 10 that make -1, there aren't any, so I'm done. So now if I state my restrictions, x cannot equal -2 and -3. So let's go over and look at number 13. So number 13, let's go ahead and we got to first factor the denominators. So I'm left with x plus 2, x plus 2. On the second rational expression, factor out an x, I'm left with x plus 2. So my least common denominator is x times x plus 2 squared. So if I look at my first term, all I'm missing is an x. So I'm going to multiply by x, so I'm left with 2x squared. On my second term, I have an x and an x plus 2. All I'm missing is an x plus 2. So I have plus x minus 1 times x plus 2, all over my common denominator, which is x times x plus 2 squared. So now if I start cleaning stuff up, I have to double distribute this. So I'm left with x squared plus x minus 2 all over x times x plus 2 squared. So now I have 3x squared plus x minus 2 all over x times x plus 2 squared. So now if I try to factor this, that's why I just come up here. I have 3x and x, 2 and 1. 3 times 1 is 3 and 2, so that's going to be positive, and that'll be negative. All over x times x plus 2 squared. There's nothing I can cancel out, so I'm done. So my restrictions are 0 and -2. So let's go ahead and go to the next question. So if I look at this next question, when you have complex fractions, you have multiple different ways you can solve it. You can either write it out and then simplify it, or you can multiply every top and bottom by a common denominator. So I'm going to go ahead and I'm going to show you both ways, just so you can see. So I have 3 over x plus 2 over 3 divided by 2x over x plus 2 minus 1 over x. So if I look at just this piece first, common denominator is 3 times x plus 2. So 3 times x plus 2. So if I multiply what's missing on that side, I'm missing a 3, which is 9. If I multiply what I'm missing on this side, it's 2 plus x. I'm sorry, it's 2 plus x, which is x plus 2. Okay. Divided by On this piece, my common denominator is x times x plus 2. So my first term, I'm missing an x, which is 2x squared, minus 1. On this term, I'm missing x plus 2. So now let's clean it up. I'm left with 9 plus 2x plus 4 over 3 times x plus 2 divided by 2x squared minus x minus 2 all over x times x plus 2. So now I'm left with 2x plus 13 over 3 times x plus 2. I'm going to go ahead and keep change flip just because I'm running out of room. On the top, I'm left with x times x plus 2. And on the bottom, if I factor this, I can't factor it, so I'm just left with 2x squared minus x minus 2. So my x plus 2's are going to cancel out. And that's it. So I'm left with x times 2x plus 13 all over 3 times 2x squared minus x minus 2. So it looks kind of ugly, but that's alright. I can't do anything. So my restrictions are, if I look at this restriction, since I can't factor, it would be imaginary, which means I don't need to do that restriction. So now if I look at this denominator, it'd be negative 2 is one restriction. And then if I go up a step, that's x plus 2, so negative 2. Here I also have 0. So that's one way I can do it. Another way I can do it, let me now take a couple seconds to erase all this. Is to multiply the top and the bottom of your fraction by a common denominator. So and I'm just going to leave my answer to show you we get the same thing. So if I look at the top and the bottom, my common denominator is 3 times x plus 2, and then x plus, so on this top it's 3 and x plus 2, and on this bottom it's x plus 2 and it's x. So the least common denominator is 3x, x plus 2. So now I'm just going to multiply this denominator to the whole top and to the whole bottom. So it's kind of like I have to distribute this to both. So if I multiply 3x times x plus 2 to this first term, my x plus 2's are going to cancel out. So I'm left with 3x times 3, which is 9x. If I take this second term and I multiply it by this, my 3's are going to cancel out. So now I'm left with 2 times x plus 2. So plus 2 times x plus 2. All over. So now if I take the bottom and I multiply this side, 3x times x plus 2, I'm left with x plus 2's. So those cancel out. So I'm left with 3x times 2x, which is 6x squared. And now I'm going to multiply this side times 3x, x plus 2. So my x's are going to cancel out. So I'm left with minus 1 times 3 times x plus 2. So now I'm just going to clean stuff up. So if I clean up my numerator, I have 9x plus 2x squared plus 4x all over 6x squared, so that's going to be minus 3, so negative 3x minus 6. So on the top, I'm left with 2x squared plus 13x all over 6x squared minus 3x minus 6. So now if I factor out the numerator, I'll factor out an x. I'm left with 2x plus 13 And on the bottom, I can factor out a 3. I'm left with x squared, 2x squared minus x minus 2. And notice it's exactly where I left off. So it's whatever you want to do, whichever method you prefer to solve. So let's try 15. 15, with complex fractions, I prefer multiplying by a common denominator, so I'm going to do that on this one. So I'm going to multiply both top and bottom by 4x times 2x minus 1. So I'm going to put that on both sides. So if I look at the numerator, first term, 2x minus 1's cancel out. So I'm left with 4x and 3x, which makes 12x squared. Second term, nothing can cancel out, so I'm left with negative 2 times 4x times 2x minus 1, all over. On the denominator, my 4x is going to cancel out, so I'm left with 5 times 2x minus 1. My denominator, my 2x minus 1's are going to cross out for my second term. So I'm left with minus x times 4x, which I can just do in my head and say 4x squared. So now I have 12x squared. That's going to be negative 8x. So that's negative 16x squared plus 8x, all over 10x minus 5 minus 4x squared. So now I'm left with negative 4x squared plus 8x, all over negative 4x squared plus 10x minus 5. So let's keep going. Factor out a negative 4x on the first. I'm left with x minus 2. On the bottom, if I factor out a negative, factors of, so can't be factored. So I know my negatives can cancel out. So I'm left with 4x times x minus 2 all over 4x squared minus 10x plus 5. My restrictions, if I restrict that, it's imaginary, so it's unneeded. Same thing all the way up. When you get down here, you do have a factor, which is right here. X can't be 1/2. If I go up any further, look at this denominator right there, x can't be 0. Let's go to the next page. So on these problems, I'm going to solve the following, and then it says be sure to check the indicated variables. So if I go ahead and cross multiply, because I have two proportions, I have 3x squared equals, here I'm going to have to double distribute. So I'll have 2x plus 4 times 2x minus 3. So now I'm left with 3x squared equals 4x squared minus 6x plus 8x minus 12. So now I'm going to subtract 3x squared. I'm going to get x squared plus 2x minus 12. Factors of 12, 6 and 2, 3 and 4, 12 and 1. None of those make 2, so quadratic formula. Negative 2 plus or minus 2 squared, which is 4, minus 4 times a times c, all over 2, because 2 times a is 2. So now I have negative 2 plus or minus 4 plus 48 all over 2. So now I have negative 2 plus or minus the square root of 52 all over 2. 52 makes 4 and 13. So that's 2 rad 13 all over 2. So now I'm left with negative 1 plus or minus square root of 13. It's a solution. If I go ahead and I look at number 17, number 17, I have to find a common denominator. So common denominator is 3x and then x plus 6. So if I multiply 3x times x plus 6, my 3x's will cancel out. So I'm left with 2 times x plus 6. Plus, if I multiply the second term by this, my 3's are going to cancel out. So I'm left with a 2 and an x plus 6. If I look at my last term, my x plus 6's are going to cancel out. So I'm left with an 8 and 3x, which makes 24x. So now I have 2x plus 12 plus 2x squared plus 12x equals 24x. So now I have 2x squared, and then I have 14x, but when I subtract 24, I'm going to get negative 10x plus 12. So I can factor out a 2. So now x minus 3 and x minus 2 equals 0. So, oops, and I wrote so x equals 3 and x equals 2 is potential solutions, but now I have to check. So if I come over here a ways and I check, let's check 3 first. So I have 2 over 3 times 3 plus 2 over 3. Does that equal 8 over 3 plus 6? So I have 2 over 9 plus 2/3 equals 8 over 9. So if I change this second fraction to be 9, multiplied by 3, I get 6. 2 plus 6 is 8. 8 over 9 equals 8 over 9. Sure enough, 3 is a solution. If I check, okay, don't know what I'm doing. If I check 2, I have 2 over 3 times 2 plus 2/3 equals 8 over 2 plus 6. So I have 2 over 6 plus 2/3 equals 8 over 8. So 2/3 is 1/3 plus 2/3 equals 1. So 3/3 is 1 equals 1. That's right. And that was a typo on my answer key. I said that was not a solution, but it clearly is. I didn't add correctly on my last one. So now technology is not agreeing with me. Let's go over here. All right. On this one, my common denominator is x minus 3. So if I multiply this first term by x minus 3, they're going to cancel out and left with 6. This term, I have no denominator, so it's just minus 4 times the denominator, which is x plus 3. And if I multiply this times x minus 3, it cancels out, so I'm left with 2. So now I'm left with 6 minus 4x minus 12 equals 2. Negative 4x minus 6 equals 2. Negative 4x equals 8. So x is negative 2. And I see where I messed up. That's not x plus 3. That should be x minus 3, which should be x plus 12, which should be plus 18, which here should be minus 16, which here should be 4. So now if I check, 6 over 4 minus 3 minus 4 equals 2 over 4 minus 3. So I have 6 over 1, which is 6, 2 over 1, which is 2. 2 equals 2. So let's go ahead and let's check number 19, or solve number 19. So I got to factor this. It's 2x plus 1 and 2x minus 1. So that's my common denominator. So my first term, my 2x minus 1s are going to cancel out, so I'm left with an x and a 2x plus 1 minus 2 on my second term. My 2x plus 1s are going to cancel out, so I'm left with negative 2 times 2x minus 1 equals, on my last term, they're going to both cancel out, so I'm just left with x squared plus 20. So now I have 2x squared plus x minus 4x plus 2 equals x squared plus 20. So now I have 2x squared minus 3x plus 2 equals x squared plus 20. So now I'm left with x squared minus 3x minus 18 equals 0. So I have x minus 6 and x plus 3. So x equals 6 and negative 3. So let's go ahead and check. I will check 6 first. So I have 6 over 2 times 6 minus 1, so that's 11, minus 2 over 2 times 6 plus 1, that's 13, equals 6 squared, which is 36 plus 20, that's 56, over x squared, which is 36, times 4, which is 144, minus 1, which is 143. So here, I'm going to multiply that by 13. 6 times 13 is 78 over 143, minus 11 times 2, which is 22, over 143. And sure enough, that equals 56 over 143 when I subtract those two. So now if I check negative 3, I have negative 3 over 2 times negative 3 is negative 6, minus 1 is negative 7, minus 2 over 2 times negative 3 is negative 6 plus 1, which is negative 5, equals negative 3 squared is 9, 9 plus 20 is 29, over negative 3 squared is 9, 9 times 4 is 36, minus 1 is 35. So these all cancel out to positive. So that's going to be 15 over 35 minus 14 over, nope, that's a plus because they cancel out, over 35 equals 29 over 35, which they do. So both of these are solutions. Let's look at number 20. Number 20, if I factor, I have x minus 3 and x plus 3. So that's my common denominator. So if I look at this first term, my x plus 3s are going to cancel out, so I'm left with x minus 3. So I have 4x times x minus 3 equals, both my x's are going to, my denominators are going to cross out here, so minus 37, minus 3 times x squared minus 9. That's just both of those put back together. So now I'm left with 4x squared minus 12x equals 37 minus 3x squared plus 27. So now I'm left with 7x squared minus 12x minus 64, because 37 and 27 make positive 64, but to move it to the other side I have to subtract it. Factors of 64, 16 and 4. So if I put 4 here and 16 here, 7 times 4 is 28. 28 and 16, hey, makes 12. But I want negative 12. So that's positive, and that's negative. So x equals 16 over 7, and x equals negative 4. So if I check negative 4 first, I get negative 16 over negative 1 equals 37 over 16 minus 9 is a number. 16 minus 9 would be 7 minus 3. So change that. That's going to be 21 over 7. So now I have positive 16 equals 37 minus 21 is 16 over 7. So that doesn't work. Huzzah! I found my mistake. My signs are flipped. That should be positive 16 and negative 4. So positive 4 and negative that. So that's positive 16, so it's negative 16 over 7. And that's positive. So positive 16 over 7, which sure enough they match. So now I'm just going to erase this because I don't have enough space. I'm going to do negative 16 over 7. So now 4 times negative 16 over 7 is negative 64 over 7 over negative 16 over 7 plus 3 equals some ugly number, 37 over 16 squared, 256 over 49 minus 9 minus 3. Woo! So if I take this and I multiply the top by 7 and I multiply this whole bottom by 7, I have negative 64 on the top over negative 16 plus 21, because I have to distribute this inside. So now I have negative 16 plus 21 is 5. So now I have negative 64 over 5. So on this mess, I multiply both top and bottom by 49. 37 times 49 is a massive number, over 256 minus 9 times 49, which is 441, minus 3. 256 minus 441 is negative 185. So if I try dividing that, 8,113 divided by 185 is 9.8. Minus 3, oh, that's negative. So negative 9.8 minus 3, that's negative 16.6. And if I just convert 64 divided by 5, that's 12.8. So I messed up. So 1,813 divided by negative 185 is negative 9.8. And then if I subtract 3 from that, I get negative 12.8. And this is negative 12.8. So yes, they both work. 4 and negative 16 over 7. All right. We got one more. So on this one, I'm going to multiply this top and bottom by x. So I'm left with x squared minus 4. On the bottom, I'm left with x plus 2. And then I'm going to make 5x over 4. So now I can just go ahead and cross multiply. So I'm left with 5x squared plus 10x equals 4x squared minus 16. So now I'm left with x squared plus 10x minus 16. Nope, it's positive 16. So now I have x plus 8 and x plus 2. So x is equal to negative 8 and x is equal to negative 2. So if I go and I check them, check negative 8 first, I have negative 40 over 4 equals negative 8 minus 4 over negative 8 over 1 plus 2 over negative 8. So I have negative 10 equals, that's negative, I'm just going to multiply both of these, actually, I lied. I'm going to multiply everybody by 8 on here, so negative 64, that's a positive, plus 4 over negative by 8 minus 2. So negative 10 equals negative 60 over 6. So negative 10 equals negative 10. So that's one solution. So now if I erase, now I'm going to plug in negative 2. So 5 times negative 2 is negative 10 over 4 equals, I'm just going to plug it in down here. I get 4 minus 4 over negative 2 plus 2. So I get negative 5 halves equals 0. I instantly know that's not a solution. So now let's go ahead and start graphing rational functions. Zoom out so we can see it all. So I'm going to go ahead and I'm going to factor the numerator. Factors of the numerator are negative 4 and positive 3. So I have x plus 4 and x minus 3 all over x minus 4. The domain is all real numbers. That should be x minus 4. Except x minus 4. No, x equals 4. My x minus 4's cancel out, so I'm left with y equals x minus 3. And this is the equation I'm now using for everything else. So I have a hole because I had a common factor at 4. So now I'm going to plug 4 into there to get my y value. So 4 minus 3 is 1, so I have a hole at 4, 1. If I look at this, I notice it's no longer a rational function. It's now a linear function. So because now it's a linear function, I have no horizontal asymptotes or vertical asymptotes or slant asymptotes. My x-intercept, if I were to look at this and I plug in 0 for y, x would equal 3. My y-intercepts is negative 3 because it's y equals mx plus b form. I know b is my y-intercept. Crosses asymptote, I have no asymptotes on linear functions, so now I can go ahead and graph. I have a hole at 4, 1. Except I messed this up drastically. That should be x plus 3. So that should be 4, 7. So I have a hole at 4, 7, which means my y-intercept is positive 3. So 0, 3 is my y-intercept. My x-intercept, I just messed all of this up, is negative 3. And I'm going to connect my dots and get my line. Alright, go ahead and flip your paper and maybe you'll have better luck on the next page. So, if we take a look at this next one, I'm going to go ahead and factor out a negative 2. So I'm left with x squared plus 2x minus 3 all over x plus 2x minus 1. So I can keep going. I now have negative 2 times x plus 3 and x minus 1 all over x plus 2 and x minus 1. So my domain is all real numbers except when my denominator equals negative 2 and 1. I have a hole at 1. So if I erase this so I have space for my new function, my new function is y equals -2 times x plus 3 over x plus 2. So if I plug in 1, I have 1 plus 3 is 4, times -2 is -8, over 1 plus 2 is 3, so -8/3 is my whole. Vertical asymptotes, so now what I'm going to do is I'm going to look at this equation to answer everything else. So my vertical asymptotes, so my denominator equals 0, so x is equal to -2. Horizontal asymptotes, I have to look at the degrees. Notice the degrees are the same top and bottom, so that my horizontal asymptote is y equals whatever my leading coefficients are, -2 over 1, which is just -2. Because I have a horizontal asymptote, I do not have a slant asymptote. X-intercepts, I have to take y and set it equal to plug it in for 0. So now I'm left with -2 times x plus 3 over x plus 2. So I'm going to multiply both sides by x plus 2. So to 0 equals -2 times x plus 3. So x equals -3. Y-intercept, we're going to plug in 0 for x. So y equals -2 times 0 plus 3 over 0 plus 2. So I have y equals -6 over 2, which is -3. So my y-intercept is 0, -3. So now to determine whether or not it crosses the asymptote, I have to take either my slant horizontal asymptote or my slant asymptote and set it equal to my function. So my horizontal asymptote is -2. So -2 equals -2 times x plus 3 over x plus 2. Multiplied by x plus 2 on both sides. So I'm left with -2x minus 4 equals -2x minus 6. I'm going to add -2x to both. I'm going to add 2x to both sides. So -4 is not equal to -6. So it does not cross the asymptotes. So now I'm ready to start graphing this. So I'm going to graph my vertical asymptote at -2. And I'm going to graph my horizontal asymptote at -2. And I'm going to plot my x-intercept at -3. I'm going to plot my y-intercept at -3. So because I have 1 down here, I know it's going to go this way. And because I have this ordered pair here, I know it's going to go this way. Let's go ahead and let's do the next one. If I look at this next one, factor out, so I'm going to pretend none of that's there. I'm left with 3 times x plus 2 over x minus 2. So my domain is all real numbers except x cannot equal the denominator, which is 2. Oh, I didn't do end behavior over here. Let's go back and do end behavior real quick. As x is going to -infinity, f of x is approaching that horizontal asymptote, which is -2. And as x is going to positive infinity, it's still approaching that asymptote at 2. So whenever you have a horizontal asymptote, that's usually your end behavior. Alright, so if I come back down here, I have no holes. Vertical asymptote is 2. Horizontal asymptote, you have to look at the degrees. My degrees are the same, so it's the leading coefficients. 3 over 1, which is 3, which means I have no slant. My x-intercept is 0 equals, it's just the numerator, if you want me to be kind, because so x equals -2, and it's just the numerator because the denominator, when you multiply it by 0, it's going to be 0. My y-intercept, if I plug in 0 for x, I have 3 times 0 plus 2 over 0 minus 2. So I have 3 times 2, which is 6, over negative 2. So my y-intercept is negative 3. Cross is asymptotes, so I have to test. It's not letting me erase that, so just cross it out. Take my horizontal asymptote, which is 3, set it equal to my original function, 3x plus 6 over x minus 2. When I say original, it's just the one that's been changed. So I just already knew I was going to have to distribute out, so I just went ahead and distributed 3 times x plus 2 in. So now I'm going to multiply x minus 2 on both sides. So I'm going to put 3x minus 6 equals 3x plus 6. My 3x's are going to cancel out, so it does not cross. So go to x at vertical asymptotes at 2, horizontal asymptotes at 3. X-intercept is negative 2, y-intercept is negative 3. So, oops, I'm not curving it. To know where your other curve is going to go, I would just pick a point and test. So I'm going to take 3. So if I take 3 and I plug it into here, 3 plus 2 is 5. 3 times 5 is 15 over 3 minus 2 is 1, so it's 15. So it's in the positives, which tell you it's going up there. So as x is going to negative infinity, it's approaching my horizontal asymptote, which is at 3. And as x is going to positive infinity, your y values are still getting close to your horizontal asymptote, which is 3. Let's go ahead and do this next one. So factor is minus 2x plus 1. So domain is all real numbers except the denominator, which is 2 and negative 1. Here I have no holes, except I don't know if I put my holes on these ones, which I now erased. Oh, I didn't have any holes. Okay, perfect. Sorry, making sure I was doing what I'm supposed to be doing. Vertical asymptotes, I now have 2, x equals 2, and x equals negative 1. Horizontal asymptotes, your degree is the same, so it's the coefficients, y equals 1. So I have no slant asymptotes. My x-intercept is 0 equals my numerator, so x is 0. My y-intercept is whenever I plug in 0. 0 squared is 0, so it's 0, 0. And determine whether or not it crosses. Take my horizontal asymptote, which is 1, set it equal to x squared times x squared minus x minus 2. So multiply by the denominator on both sides. So now I'm left with negative x minus 2 equals 0. So x equals negative 2. So when x is negative 2, it's going to cross it. So to find the y value, I take negative 2 and I plug it into that. So negative 2 squared is 4 over negative 4 times negative 1. So this is 4 over 4, which is 1. So if I graph my horizontal asymptote at 1, and my vertical asymptote's at 2, and at negative 1, and then my x and y intercept, so I know it's going to go down like this, and I know it's crossing at negative 2, 1. So let's plug in negative 3 to see where it would go. So negative 3, if I plug in negative 3, I get 9 over negative 5 times negative 2, which is 10. So that's going to be like there. So that means it's crossing like this. So now I have to test a value over here. Let's go ahead and plug in 3. So 3 squared is 9. So 3 minus 2 is 1. 3 over 4. So 9/4. So now if I do end behavior, as x is going to negative infinity, y is approaching that horizontal asymptote, which is 1. And when x is approaching positive infinity, my y values are approaching that horizontal asymptote, which is 1. Go ahead and flip. If I look at this next one, I'm going to go with factor, x plus 2, x minus 2, x minus 1. So my domain is all real numbers except x cannot equal 1. I have no holes. Vertical asymptotes, x equals 1. Horizontal asymptotes, my horizontal asymptotes, I have none because it is top heavy, which means I have a slant asymptote, which means I have to divide this. So I'm going to do synthetic division of 1. My degree of 2 is coefficient's 1. My degree of 1's coefficient is 0, and my constant is -4. So bring down the 1. 1 times 1 is 1. Add them up, I get 1. 1 times 1 is 1. Add them up, I get -3. We disregard the numerator, so my slant asymptote is y equals x plus 1. My x-intercept, I take the numerator and set it equal to 0. So x equals plus or minus 2. My y-intercept is -4 over -1, because I just plugged in 0 up here, so those would go away. So -4 over -1 is 4. Crosses asymptote, I'm going to take my slant asymptote and set it equal to my function. Multiply by x minus 1 on both sides. I'm left with x squared minus 1 equals x squared minus 4. Sure enough, my x squareds cross out, so no. So I have a vertical asymptote of x equals 1. And I have a slant asymptote of y equals x plus 1. So here, and then I'm just going up the diagonals. Up 1 over 1, up 1 over 1. Positive 2, and -2, and 4. So this goes like this. As x is going to negative infinity, my y values are going to negative infinity. And as x is going to positive infinity, my y values are going to positive infinity. If I go ahead and I do this one, factor the top, I can't. Factor the bottom. I'll do this actually in a different color. X plus 6, x minus 6. So my domain is all real numbers except x cannot equal plus or minus 6. I have no holes. My vertical asymptotes are x equals 6, x equals -6. Horizontal asymptotes, I have none. Nope, I lied. I don't have none. It's not top heavy, it's bottom heavy. When it's bottom heavy, my horizontal asymptote is 0, which means I have no slant asymptotes. To find my x-intercept, I take my numerator and set it equal to 0. So x is 1/3. To find my y-intercept, replace 0 with x was 0, so I have -1 over -36. So I have 0 over 1/36. To determine whether it crosses, I take my horizontal asymptote, I set it equal to my function. 3x minus 1 over x squared minus 36. So now I have 0 equals 3x minus 1. So x is going to equal 1/3. Which, notice that's also my x-intercept. So I know my y-intercept is 0. So if I go ahead and start graphing this, I have horizontal asymptote at 0. Vertical asymptotes at 6. And at -6. I have an x-intercept at 0, 1/3, which is where it crosses, and a y-intercept at 136, which I'm just guesstimating. So since I have to touch this dotted line and this dotted line, it's gonna go something like this. And then if I plug in -7, 3 times -7 is -21, so that's -22 over, that's going to be a positive number, 49 minus 36 is 13. So negative over a positive, that'll be negative, so that's down here. So then I know it's going to be up here when it's positive. But if you didn't know that, you could also have plugged in +7. If I go ahead and look at this, it says write a rational function with the given asymptotes. So x equals 2. So since x equals 2, that's a vertical asymptote. And y equals 3, that's a horizontal asymptote. So answers can vary. But y equals, my vertical asymptote has to be on the denominator, x plus 2. My horizontal asymptote, it just means I have a coefficient of 3, which means my degrees are the same. So down here my degree is the same, it's 3. So my degree is the same, which is 1. So I have to have a degree of 1 up here, and then put the coefficient to get 3. If I look at the next one, x, 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 those are all vertical, which means those are all my denominators. So x plus 3, x minus 2, and x in the front. Since my horizontal asymptote is 0, that means it's bottom heavy. So if I were to distribute that, that would mean I'd have a degree of 3, which means my numerator needs to be anything less than 3, which is x squared. You could have put a coefficient in front of that, you could have done a whole bunch of different things, but that's the way that I did it. If we look at this last problem, it says write the following. Given the picture, write the equation. So I have a lot of information. I have a hole at -2, -1. I have a horizontal asymptote at 1, so y equals 1. I have a vertical asymptote at x equals -1. My y-intercept is at 0, 3, and my x-intercept is at -3, 0. So I know my denominator has to have x plus 1, and I know my numerator has to have when I solve for x, has to have -3, so that's going to be x plus 3. And I have a hole at -2, which means x plus 2 has to be a common factor. My horizontal is y equals 1, which means it has to have the same degree, which right now it does. It has to have coefficients of 1, which right now it does. Vertical asymptotes, -1. So now y-intercept, if I were to check my y-intercept by plugging 0 in for all my x's, I would get 3 times 2, which is 6, 6 over 2, so that's 3, that's satisfied. So I think I'm good. So now I'm just going to double distribute this to get my equation. X squared plus 5x plus 6 over x squared plus 3x plus 2. So that is it. If you have any questions, make sure you go ahead and you contact me so we can go over it. And I will see everybody next class.